In this video, an ENACT coach will model 2 strategies teachers can use to support students in taking ownership of computational thinking practices. We call these strategies prompting and pointing out. The coach will model how you might prompt students to use computational thinking by making suggestions about how a student can use a CT practice to approach the problem. Then the coach will model how you could point out when you observe students using a CT practice, whether they realize they were doing it or not. The examples in this video focus on fraction word problems, but the ideas could apply to any type of word problem. Let's watch an example of the coach prompting a student to use abstraction. The student has already started working on the problem, and the coach suggests using abstraction to debug a strategy that is not working.
Let's read the problem you're working on. A turtle can walk 1/8 of a mile in an hour. How many hours will it take the turtle to walk 1 1/4 miles? Okay, so what have you done so far? You subtracted? All right, so you said 1 1/4 minus 1/8 is 1 1/8. All right, and so what does that 1 1/8 mean in the problem? You're not sure? Maybe we can use some abstraction to help us thinking about that. So what if we drew a picture of the problem and use that to help us make sense of what the numbers mean? Sound good? All right, let's try that. So if we're drawing a picture, we know this problem is about a turtle walking, right? So that number 1 1/4, let's start there. What does that mean in the problem? What does it tell you about the turtle? Yeah, so it's how far he's walking in all, right? So how could we draw a picture of that? Maybe draw his path and then just label the length? I think that makes sense. All right, so what about that other number we're working with, that 1/8? What does that mean in the problem? Yeah, so it's how far he's walking in just 1 hour. So not the whole distance, but just part of it. So how could we show that on our picture? Yeah, we could just mark it down as part of the distance and say that's how far he goes in 1 hour. Now, you came up with 1 1/8. Where would we add that to our picture? Where would that go? Yeah, so you started with the 1 1/4 and you took away that 1/8. And so what's left is the distance he has left to go, 1 1/8 mile. So that makes sense, but is that what the problem was asking? No, so that's not exactly what we were trying to find out. So it seems like subtraction wasn't the right operation to use here. So maybe we can keep using abstraction to help us decide what to do next, okay? So let's erase your 1 1/8 and maybe also your equation, because we know that wasn't quite right. And look at this picture again. So what are you trying to find out? If it wasn't the distance left, what were you trying to find out? Yeah, so how many hours, so an amount of time it's going to take him to walk the whole distance, right? So how could we put that into our picture? Yeah, no, I like that idea. So we want to mark the whole length and make sure we're saying how many hours, because that's what we're trying to find out. Okay. So does this picture help you decide what operation you might use to solve the problem?
It is important to give students a chance to suggest how to add new information to the picture to make sure they're getting practice in using the CT strategies. If students are not sure how to proceed, it can be helpful to offer suggestions. Next, let's watch an example of the coach prompting a student to use decomposition to solve a fraction word problem.
Let's read the problem you're working on. Kendall uses 2 3/4 pounds of potatoes every week. How many pounds of potatoes does Kendall use in 3.5 weeks? It can be really challenging to think about fractions at the same time you're trying to also make sense of what's going on in the problem. I wonder if there's a way we could use decomposition and just focus on one of those things at a time. Can you think of a way that we could just focus on making sense of what's happening in the problem? What if we put simpler numbers in just to start out? So we could say Kendall uses 2 pounds of potatoes every week. And how many pounds of potatoes does Kendall use in 3 weeks? Maybe if you just focus on making sense of what's happening in that problem and figuring out what you want to do with the numbers, then afterward you can worry about working those fractions back in.
In that example, the coach suggested using simpler numbers to help students make sense of the problem. Another idea is to change the situation in the problem to something more familiar to students, such as reading 2 3/4 pages a day for 3.5 days, or spending 2 3/4 hours per week practicing a sport or an instrument over 3.5 weeks. Now let's look at an example of the coach pointing out how she saw a pair of students using decomposition as they worked on a fraction word problem.
Logan and Amari were working on this problem, and they did something cool I want to share with you. So the problem says, Jamarcus plans to build a fence 5 1/3 yards long at the back of his garden. How many 2/3 yard sections of fence will Jamarcus need? Now, Logan and Amari weren't sure what to do right at first, so they just focused on trying to make sense of what was going on in the problem. They were thinking about Jamarcus adding these sections of fence, and they thought about how long the fence would be after each section was added. And they showed this thinking with number sentences. So they said, okay, when he just has one section, it'll be 2/3 yard long. And then with 2 sections, it's 1 1/3 yard. 3 sections, it's 2 yards. And then as they were doing this, they realized that what they were trying to figure out is that there's some number, and they weren't sure what that number was yet, that when they multiply it by 2/3, they get that final length of 5 1/3. So this was cool because it took them to a place where they knew they couldn't use multiplication, but they could rearrange this equation. So it said 5 1/3 divided by 2/3 equals what? So they decided they could use division. I thought that was such a cool way to use decomposition. They weren't sure what to do first, so instead of trying to find the operation right away, they just focused on making sense of what was happening in the problem. And that got them to a place where they could decide what operation to use.
In that example, the coach shared the students' thinking. In your classroom, students can share their own thinking, and you can point out how what they did shows decomposition or other CT practices. Let's watch one more example of how the coach points out how students use abstraction as they solve a fraction word problem.
I know a lot of you are working on this brownie problem, and I wanted to tell you something I saw. So the brownies problem says, Raymar ate 1/4 of a pan of brownies. Kaylin ate 1/4 of the rest of the pan of brownies. What part of the whole pan did Kaylin eat? So I was talking to Micah about this problem, and Micah said they used abstraction to help them make sense of a problem, part of the problem that was confusing. So Micah said the hardest part to understand about this problem was this part, 1/4 of the rest of the pan. It was hard to know what exactly that meant. So Micah drew a picture to help make sense of it. So what did you draw, Micah? Okay, you started by drawing the brownie pan. That makes sense. So that's the whole pan. All right, and then what did you do? You drew 3/4. Why 3/4? Okay, so you were thinking about Raymar eating 1/4. So you made the fourths and then shaded 3 to show what was still left? All right, and then what? Oh, interesting. So you were thinking about this 1/4 of the rest of the pan, and now that you could see that the rest of the pan was 3/4, you actually knew that what that was asking you to find is 1/4 of 3/4. And that's a problem you know how to solve, right? Great job using abstraction to make sense of this problem.
As you plan to prompt and point out how students are using CT practices, consider these questions. What are some strategies my students could use to solve the problems in this lesson? How might a CT practice already be a part of or add to those strategies? How might I recognize when I see my students using a CT practice? And how might I identify when it would be helpful to prompt a student to use CT?